Typhoons are giant storms, some of the most powerful forces of nature on our planet. They can span hundreds of miles across and last for days, wreaking havoc on everything in their path. They bring strong winds and heavy rain, often leading to severe flooding and widespread damage. The sheer force of these storms can uproot trees, destroy buildings, and cause massive power outages. These storms form over warm ocean water, where the heat and moisture provide the energy needed to fuel their growth. As they gather strength, they can transform from a simple tropical depression into a full-blown typhoon. We also call them hurricanes or cyclones in different parts of the world, depending on where they occur. In the Atlantic and Northeast Pacific, they're known as hurricanes. In the Northwest Pacific, they're called typhoons, and in the South Pacific and Indian Ocean, they're referred to as cyclones. Imagine a spinning top. That's how a typhoon moves. The rotation is due to the Coriolis effect, which causes the storm to spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It has a center called the eye, a calm area surrounded by the strongest winds. The eye can be deceptively peaceful with clear skies and light winds, but it's encircled by the eye wall where the most intense weather occurs. These storms are categorized by their wind speed from a gentle breeze to a furious roar. The Saffir-Simpson scale is often used to classify them, ranging from Category 1, with winds of 74 to 95 miles per hour, to Category 5, with winds exceeding 157 miles per hour. The strongest typhoons can have winds faster than a cheetah, reaching speeds of over 200 miles per hour. These powerful winds can turn everyday objects into deadly projectiles. They're a natural part of our planet's climate, but their intensity can be influenced by global warming. As sea temperatures rise, the potential for more powerful and destructive storms increases, posing greater risks to coastal communities worldwide. Warm ocean water acts like fuel for typhoons. The heat from the water provides the energy needed for the storm to grow and intensify. As the water evaporates, it rises and cools, forming storm clouds. This process releases latent heat, which further fuels the storm. The Earth's rotation makes these clouds spin, creating a powerful cycle of wind and rain. This spinning effect, known as the Coriolis effect, is crucial for the formation of a typhoon. Imagine a pot of boiling water. The steam rising is like the warm air forming the typhoon. Just as steam rises from the pot, warm, moist air rises from the ocean's surface. The warmer the water, the stronger the typhoon can become. This is because warmer water provides more energy, allowing the storm to grow larger and more powerful. Climate change is making oceans warmer, which could lead to more intense storms. As global temperatures rise, the frequency and severity of typhoons are expected to increase. These powerful storms usually form in tropical regions during specific seasons and can travel thousands of miles across the ocean. Their paths can be unpredictable, causing widespread damage wherever they make landfall. Typhoons can cause significant damage. Strong winds can tear down trees and buildings. Heavy rains can cause floods and landslides, washing away homes and disrupting transportation. People can get hurt by flying debris or drown in floodwaters. Animals lose their homes and struggle to find food. The environment also suffers, with damaged coral reefs, eroded coastlines and polluted water sources. The aftermath of a typhoon can be devastating, leaving communities to rebuild their lives and infrastructure. Early warning systems, like weather satellites, play a crucial role in monitoring and predicting typhoons. These advanced technologies provide us with real-time data and imagery, allowing meteorologists to track the development and path of these powerful storms. Ocean buoys equipped with sensors collect vital weather data from the sea surface. This information is essential for understanding the intensity and movement of typhoons, helping us to forecast their impact more accurately. With this data, authorities can issue timely warnings, giving people the chance to prepare, evacuate if needed, and take necessary precautions to stay safe. This early action can save lives and reduce damage. In addition to early warnings, we can also build stronger homes designed to withstand the forces of nature. Reinforced structures in typhoon-prone areas are essential for minimizing damage and ensuring the safety of residents. Seawalls and flood barriers are critical defenses against storm surges and flooding. These structures help protect coastal communities from the devastating effects of high winds and rising waters. Planting trees on hillsides and implementing landslide prevention measures are also important. Trees help stabilize the soil, reducing the risk of landslides and protecting the environment. Understanding how typhoons form and their potential impact is crucial for developing effective disaster preparedness plans. Meteorologists and disaster response teams work together to analyze data and create strategies to mitigate risks. By taking proactive steps to prepare and mitigate risks, communities can enhance their resilience against typhoons. Regular disaster drills and installing storm shutters are practical measures that can make a significant difference. After a typhoon, swift recovery efforts are essential. Repairing damaged buildings and restoring infrastructure help communities get back on their feet and reduce long-term impacts. Through a combination of early warnings, strong defenses, and community preparedness, we can reduce the devastating effects of these powerful storms and protect lives and livelihoods.